Hi, my name is Steve Pranovo. Today I'm happy to talk to you guys about new technology that we're bringing to WSL called WSL G, which essentially will enable you to run X11 and Wayland application within WSL. So what is WSL? WSL is the Windows Subsystem for Linux. In a nutshell, it's an infrastructure that allows you to run like Linux application inside of Windows. If you want a little bit more detail about WSL, there's a lot of information out there, and you can also look at our other talk that we did earlier on WSL graphic architecture. The key thing with WSL today is that it's a terminal-only experience. So you can run Linux application, but only console application, and then standard out basically get redirected over to Windows. So you can run Linux inside of a terminal. The most requested feature for WSL has been twofold. One, getting the GPU inside of WSL, and that was the subject of our other talk. So I would invite you to go in and take a peek at that. And the subject of this talk is the ability to go and run GUI application. Whether it's your favorite editor or some tools that you must absolutely use. There's been demand of being able to go and run these applications inside the WSL. But wait, people can go and say, hey, yeah, but you can already run X11 application in WSL today. So for example, you can go and run an X server inside of WSL, and then you can run an X client on Windows. And there's a lot of instruction and very useful YouTube video that goes and show you how to go do this. And I think even Penguin distro kind of has this all built in. It works, but it's not a really great experience, because fundamentally what you have is a desktop in a window experience, right? You don't have an integrated desktop. What you have is you have your Linux desktop, you have your Windows desktop, and you have to kind of go back and forth, right? Potentially scroll. With multi-mon, it doesn't work very well. Performance is also not great, because fundamentally all the bits are kind of copied over. There's no Wayland support. Wayland only work locally. There's no support for over the network. And it doesn't generally work out of the box either. So you have to kind of go out of your way to do this. And essentially what we wanted to go do for WSL is bring kind of true integration into Windows, so that you can basically have a desktop like this, where you have some application that are native Win32 application that runs on Windows itself, and you have Linux application that are running inside of a virtual machine and are being remoted over, but all of those details hidden from the user, so that it just looks like a unified desktop. And for example, in this picture, I'm running several Linux applications, including the browser that you see there. That's actually the Google Chrome, but the Linux version, not the Windows version. So that's kind of what the experience we want to go and achieve. So what's our approach? So we looked at different way of doing this and what other folks had done kind of similar. We fundamentally decided to build on top of Weston. Weston, for folks that are not familiar with it, is essentially the reference or simple compositor for Wayland. And the idea was that Weston already supported the ability, or already had an RDP backend, where you could basically run the Weston desktop and just remote it to another PC through this RDP. In a nutshell, what we're doing is we're taking Weston, we're taking this RDP backend, and we're extending it to teach it how to basically do remote application. So instead of remoting the desktop, we remote individual window, and then we can take those windows and integrate them with the rest of the Windows desktop. And you'll hear me refer to two things in particular. There's something we call RAIL, which stands for Remote Application Integrated Locally. This is essentially something we've been doing for many, many years, and is part of the RDP protocol. It allows us essentially, like the name state, to remote an application and to integrate it locally into your desktop. And then we have a variation of this called VAIL, or Virtualized Application Integrated Locally. The way to think about VAIL is that it's RAIL, but because we're inside of a virtual machine, and inside of a virtual machine, we can play other trick. We don't have to go over the network. We can share memory between the guest and the host. We can have essentially a more efficient protocol to kind of move bits between the client and the server. But outside of that, it's the same. It's the same concept. So that's for graphics. So for pixels, we're using essentially Weston. And then for audio, we're running Pulse. So we're running a Pulse audio server. And then we wrote some like plugin to Pulse that allows us to take the audio and essentially like shuffle it to like our Weston compositor. And then Weston can take that audio and like mix it over like the RDP channel and send that over to the client. And similarly, like if the user is running a microphone on the host, RDP already support taking the audio from the microphone, sending it back to the RDP server that's running inside of our Weston compositor. And then we can take that audio and reshuffle it back to Pulse so that we can have both like audio in and audio out. And all of this is being built with the intent of being able to like contribute back. So it's all open source. Like everything that we're doing in RDP, it's all documented. Like there's protocol documentation you can go and look at. And there's no secret sauce or anything like this. Everybody can redo exactly the same thing that we do here. So here's kind of a quick overview of WSLG. So at the heart of it is basically the Weston compositor. So the Weston compositor support multiple shell. So it already has like something called a desktop shell. It has an IVI shell like for automotive. It has also like a full screen shell that is used for full screen app, like kiosk type application. And so in our case, we basically wrote a new shell that is geared toward remoting app, because in our case, we don't really have a shell/desktop. We don't draw a widget or anything like this. It's really about capturing the content of the top level window and remoting this over. So there's a couple of different rules that our shell has to basically follow. And then Weston opened like a Wayland socket that allows like native Wayland application to connect to it and run. And we also run the X11 server that basically give us like an actual X server, so we can go and run X11 application. So we're running X11 in rootless mode, so that basically all of the X application are being rendered by the X server, and then the X-Wayland take those output and forward them over to like our Weston compositor. And then inside the gas, we're also running a Pulse audio server that's hosting our RDP sync and RDP source for audio in and audio out. And we forward those over to our compositor where we're running the RDP backend, but we're running a greatly enhanced RDP backend. Like, so we added support for things like, for example, multi-mon. So now, like, you can go run all of this in multiple monitors, and as the monitor comes and go, like, the application will see the monitor comes and go. And added support for things like cut and paste and things like this over like the RDP channel. So we start essentially to have an RDP server that is like fully functional. That allows you to do like almost the same thing that you can do, like say remoting into a Windows box. And on the Windows client, we're essentially just running one of our existing RDP client. In particular, we use MSTSC, which is probably the most known RDP client. We're using a slightly modified version of MSTSC that's going to ship with Windows. There's a couple of small little things we had to go in and tweak. But for the most part, it's basically the same client. So why base this on RDP Rail and Vel? So there was really kind of like at a high level 2 different approach we could have looked at. There was kind of like the Google approach where they decided to basically just go and remote the Wayland protocol and then run a Wayland server or Wayland compositor on the host. For us, we don't really have a Wayland compositor on the host. It would have been, hey, rewrite like a Wayland compositor from scratch. What we had instead was basically like that same kind of technology of like remoting application, we had technology already like really mature around that, right? Like with RDP, we've been remoting application like this for many years. We have really big business built on top of that. So today, for example, we have this thing called Azure WVD or Windows Virtual Desktop, where you can go and run application in the cloud, and we just go and remote those applications, not the whole desktop, but just those applications, and integrate them onto your desktop so that you can have a PC where some app are running locally and some app are running in the cloud. So technology that we understand well, we understand the security around it. And it was very interesting for us to kind of build on top of that, because it gave us basically both the, hey, we can reuse a lot of that client, we can reuse a lot of that experience, but it also basically allows us to kind of remote both X11 and Wayland in a completely like invisible way. And then if you're over a true network, but then we go and use something like the rail protocol. If you're over a VM boundary, then we can go and switch over and use the more efficient VEL protocol over the VM boundary. And it's all documented, open source, and it was giving us kind of a good way to contribute back to Weston and make it kind of a real shipping environment. So the thing that's important to realize is the way we built this, we built it for really remoting transparency, and we did not build this specifically for WSL. So yes, we're running Weston inside the WSL, and in this case, we're veiling the application out and integrating them into the desktop. But it's not specific to WSL. You can, for example, spawn an Hyper-V VM, go and run Weston in it, and you'll be able to veil out of that VM as well back onto Windows. But if you want, you can also just run Weston on a like Linux PC. And in this case, we can connect over TCP, and you can basically rail the data out. And that's something that we do during our testing, where like on my dev box at home, I have a little Raspberry Pi, and I go and run the Weston compositor on the Raspberry Pi, and then I can basically just like TS into it, and I can remote application running on the Pi back onto my desktop, and I get the same experience that I do out of WSL. So there's really nothing specific about WSL. It's really about building a full-fledged RDP server in the backend of Weston, as one of the backend for Weston. And this approach, one of the nice things is, if, for example, there was ever a demand to go and say, oh, we would like to go and run some of these Linux applications, maybe like the same way as we do for Windows with WVD, maybe we could run some of these Linux app in our cloud, and then we could just go and stream them to like devices using the same model that we do today. So that was pretty appealing. So it gives us all of these niceties. Okay. So how does that fundamentally work? So the very first thing that we do essentially when we establish the RDP connection in Rail is we have to mirror the desktop. So for example, if you have 3 monitors oriented a certain way, we're going to basically mirror that exact position of the monitor inside of the virtual machine. And that's important because whether you're trying to remote application, a Win32 application on Windows, or whether you're trying to remote X11 application in Linux, X11 app are basically aware of their placement on the desktop, right? So they have to be aware, like how many monitor is there? Where am I on a specific monitor? So in Rail mode, essentially, we always mimic things. So as we initialize, I have a little picture here. As we initialize, hopefully if we have 2 monitors, we'll basically open RDP connection, send that configuration. So that will initialize, like, the WL output to map exactly. So you'll have the exact same monitor at the exact same resolution, orientation, position, like all that stuff. There's a little bit of GUI with like coordinate system, because the RDP desktop has a certain coordinate system. RDP input has a different one, and Linux has a different one. So we do a little bit of shuffling to get the coordinate to match. But then the idea is, like, as the desktop changes, so for example, if the user go and change the resolution, then we send that information over and we go and reflect it. So that basic, and then we reflect it back to client as well. So that essentially, if you use a tool to look at the X desktop, you'll see that it always essentially map to your configuration of your Windows desktop. And we've taught like Weston how to deal with like monitor arrival and monitor departure and like monitor changing resolution and things like that. So that it just works today. And then once we've established our desktop so that the Linux environment and the Windows environment have desktop that kind of look like one another, essentially what we're doing is we're proxying the top level visuals, right? So whenever like you have like a, for example, visual that gets created or say a surface, a WL surface in Wayland that gets created, over the RDP connection, we basically go and ask the RDP client to go and say, hey, can you go create a window of this size at this location? And then whenever, like, for example, there's an update, so if there's an area of the surface that gets damaged, that damaged area basically gets sent over. That piece of like how we send damage, that's the piece that's going to change the most based on the type of connection that we have. So for example, if you're connected over something like Rail, where we actually have to copy pixels, then like, we'll have to copy because we're over like a physical connection, maybe like a TCP connection or something like this. So we have to physically copy pixels. If we're over, like say a VM boundary, then we don't really have to copy things. We can basically just play like memory management trick and share surfaces. So yeah. When surface gets destroyed, basically destroy gets sent over. Move resize is a little special. We actually have two versions of it. So when you have like raw input, you just send the input over to the host, to the guest. You let the guest handle the input, and the guest may decide to move the surface, and as the surface move, basically there's a message sent back to the client that goes, say, hey, this window has moved, please update, and then it updates. We also have a variation of this that we're playing with, where we can do all of the window movement locally in on the guest. On the host, that allows basically for like smoother window movement still. But in the demo that we're going to show a little bit later, we're using the server-based move. So how does it work to send all of those dirty? There's kind of like three big paths. So the first one is, for example, when we're actually running Rail. So that means we're over a connection, like maybe like TCP or something like this, where the machine are physically disconnected and we have to copy the pixels. So in this case, we have what we call a composition beat, like the same composition beat essentially that Weston already uses today to compose the desktop. So you can think about it in terms of that you have your like Wayland app or like, X app through X Wayland that is sharing buffer with like the Weston compositor. And then there's a composition thread that like on a timer wakes up about like every 60 hertz. In this case, like for example, if you're on a remote machine, it's actually going to be like on a timer. If you're on a local machine, we can actually go use things like, the actual VSync of the monitor. And then the idea is like, hey, as that composition thread hit, like whatever has been made dirty during the last period is being sent over the network, and then it's being received on the Windows side, and then we go and upload it to like the proxy visual so that they always kind of remain in sync. So that's if we're like over the network. When we're over like just a VM boundary, then we automatically switch over to like Rail extension to the RDP protocol. And in this mode, essentially what we do is we have these shared buffer that come from the application that are shared with the compositor. Through some other magic, we can make those buffer essentially visible directly to the host so that the host has access to the same memory. And then when we have damage area, instead of having to kind of copy this over to the host, we can just send that notification of the damage area to the host. And the host essentially will take that damage area and upload it to the real surface. So in this case, for example, if your GPU only support the X11, what we'll do is we'll take those damage area, we'll copy that into like a staging surface for the GPU, and then we'll ask the GPU to copy from that staging surface into the final like swap chain for the window. We call it the comp swap chain. And then at that point, the data is now visible to like our compositor. And then our compositor can decide to either use it to composite a new desktop, or it can basically go and use the display to directly display from that surface with no other copy. But essentially, you end up with 2 copy compared to, say, if the application had run natively on Windows. If you have the X12, the X12 has this nifty little trick where it leverages like support in VDMM to basically wrap surfaces around existing memory. So we can go and create a heap like directly around the staging buffer that we receive from the guest. So we don't have to do that first copy. So now we have a staging that is basically directly onto the buffer that we've received. And then in a single copy, we can basically get this into the decomp swap chain. For software rendering, that's really kind of like the best we can do, because the software renderer, like, had to render to like system memory. And then on Windows side, once you bring things onto the GPU, well, you have to do at least 1 copy to get the data onto the GPU memory to be used. So as basically damage application that cause damage, we basically just forward those over to Windows, and it just adds a little bit of latency, but we no longer have to do this like beat every 60 hertz like this. And this is, for example, for a scenario, I should have probably mentioned that before, but this is for a scenario where we're using software rendering, right? So we're working on getting GPU acceleration, and Jesse's has a talk following later that talks more about how we're bringing support for GL and CL accelerated. But we're still going to end up with a lot of GPUs that just don't have a driver updated to support Linux, and we still wanted to be able to support those platforms as well. So our support for GUI application run with both on platform that don't have a virtual GPU and where all the rendering is done in software, or on platform that have a virtual GPU, in which case you're going to have accelerated GPU. So in this case, this is a software rendering. We end up with like 1 extra copy from running the application locally, and it works pretty well. The demo that we'll do later isn't actually quite that. It's kind of in between the first slide and this one. So yeah, and then to achieve 0 copy, we really need to have the VGPU. So with VGPU, what we're working on enabling is essentially the ability for application that use EGL or GLX to go and leverage a hardware acceleration through Mesa and through like the 12 driver that we've exposed. And in this case, the buffer that are allocated by the application and share with the Linux compositor are actually video memory buffers. So they're not like system memory, they're actual memory like on the GPU that the application can go and render directly on. And those buffers are basically share with the host, like our DHG kernel, our WDM power virtualization projection of the GPUs allows us to share surfaces between the guest and the host. So those buffer can also be accessible directly like from the host. So on the host, we reopen essentially the same memory. And then what we can do is like the quote-unquote window on the host side isn't really a window with like, its own memory and things like this. Instead is what we call like a decomp visual. And it's basically just kind of a little pointer to like a swap chain. And we can take that swap chain that was shared by the guest, and we can basically just like hook it up to the visual tree. So the compositor essentially consume those buffer directly without introducing extra copy or anything like this. So we don't yet have that up and running on Linux. That's what we're working toward. But we have model like this running Windows on Windows today. And that gives us a kind of a nice 0 copy where like there's very minimum amount of overhead. Essentially, as you have a damage, we send the damage over. And like, I put like 100 microsecond of overhead for transport. That's really like usually on a fast CPU, it's actually like less than that. But, if you have a not too fast CPU, that's about the right order of magnitude. Okay. So that's for Avail and kind of like roughly how it works. How are we actually packaging this and getting this to work inside of Windows and like servicing it? So we're introducing this concept that we call the system distro. So if you're familiar with WSL2, we essentially have this Linux kernel. And then against the Linux kernel, we go and run different like user distro. So, and we're introducing this concept of the system distro, which is essentially a distro that we package together that has like all the components we need. So it has like Weston and Wayland and Pulse Audio, and it has all the dependencies that it needs, but it runs kind of isolated from the user distro. And we just project like the various socket and environment variable, etc. the user distro needs in order to connect to it. It's sort of like a container, except that we don't actually use a kind of container like a Docker container or something like this. We're really running in like an isolated like mount and PID space. And this allows us to make sure that like, a user doesn't accidentally like change a dependency and all of a sudden like things break on it. It just always works. And each distro, because WSL allows you to run essentially multiple distro against your kernel, so you may install Ubuntu, you may install Debian, and they're going to run side by side. Each of these distro gets their own instance of this system distro. And each of the system distro has an RDP connection back to the host. All of this is kind of like invisible to the user. The user doesn't really has to know. It's just that, hey, I just launched my user distro, and look, there was a Wayland server available, and there was a X server and a Pulse server available, and they just happened to work. Yeah. So in terms of servicing, all of this is actually shipping out of band. So it's not shipping as part of Windows. It can be updated outside of Windows, like release cycle, which makes it really interesting for us to be able to kind of update this quickly. It's kept always up to date. There's really kind of two ways to do this. So if you just want to let Windows do it, you can go into the settings, Windows update option. You can go and say, hey, just have Windows update stuff for me, and we'll just take care of it. We'll update it for you, and you don't have to worry about a thing. Or users that want to be under more control can decide like, no, I'll decide when, like, I pick update. And then we have this really nice just command line from a command prompt. You just type WSL -- update, and then that's going to go and put whatever latest, install it, etc. Once WSLG comes into our Windows Insider pool, that's how people will go get it. When you go into WSL update, at some point, poop, it's going to show up, and boom, you're going to have GUI application supported all of a sudden. So the system distro itself is read-only. So it's all packaged up, all read-only. We don't want user to put files there or things like this, because the servicing model is essentially like we download a new one, we throw away the old one, and then you start running on the new one. Actually, like we have this concept of a rollback, so we kind of keep the last one as a rollback just in case something goes bad. You can always go back one. But the idea is a replace, not some kind of like, oh, we'll merge the files that you had locally with the files incoming. It's like we throw away the whole thing and replace it all. So because of that, we don't want the user to go in and put things into it, because we would essentially like lose that data on update. But what if the user wants to go and run a custom distro, doesn't want to run the one that we're providing? So for that, we're actually giving a way for user to go and say, hey, if you really want to go and build your own distro, and this is what you want to use instead of using ours, totally. You can just go build it, and you can change the WSL config option, and you can go in and run your own. All the code necessary to go and build a system distro and instruction to build a system distro is all going to be public. So anybody can go and kind of build their own. The fact that it's read-only for us is really just the, hey, this is how we're going to update our default. We don't want to screw it up and lose some of your file, right? So please don't put your file here. And if the user is using a custom distro, when we do the update, we'll only update the default system one. We're not going to touch the user one. So the user can go in and do their own experiment and build their own things. And the idea is that, yes, everything works out of the box, right? So you just go and enable WSL, like as you installed it, you go to the Windows Store, you go in and download one of the WSL distro, maybe like Ubuntu or Debian or something. You install it, and as you launch it, everything just works. Like you can just launch a GUI app, and you don't have to worry about how that works. The Linux application appears in the start menu. So in particular, if you have application that have a .desktop file, we have a little agent that goes and enumerate those, and will go and reflect those and add those to your start menu. So then from the start menu, you can just go and click on those, and it will launch like WSL, and will go and launch that application, just like as if you had if it was a local Windows application. And what if you don't want to use this because you actually prefer to use like an X server and client, like maybe you were doing today? That's totally fine. You can go into the WSL config and you can go disable WSLG, and then you can keep today's behavior if you want to. Maybe you're just happy with console and you just don't want this, and that's totally fine. And a preview of this is coming to the Windows Insider pretty soon. I can't give you an exact date yet, but soon. So we'll end with a little demo of how that looks like.
Hey, Lior.
Hey, Craig, how's it going?
It's going good. I'll see you later.
Okay, we are now in the Q&A section. So, is Jesse here? Yes.
Yes.
Would you like to start summarizing what has been discussed in the QA channel, and then we can move forward with other questions?
Yeah, I'll go ahead and field some of these that we've kind of already talked about to Steve, and we can summarize. So first off, questions that were kind of answered in the slide presentation just before we got there. Do we have plans to support zero-copy buffer sharing? Yes, we talked about that a bit. Do we get 2 Weston instances for 2 Linux apps? No, you get 1 Weston instance per distro that you're running. The question of does drag and drop work? And asked a couple times. Basically, not yet. We'd like to. Copy and paste does work though. Question of is it basically just the RDP backend for libweston that is new on the Linux side? Steve, do you want to?
Yeah, no, it's a little bit more than just the RDP backend. The RDP backend is where most of the changes are for Weston, but we also had to change the shell. So Weston already is built with multiple shell. Like, there's the IVI shell for automotive, the desktop shell, the full screen kiosk shell. So we added another shell for remoting app. So some of the rules are a little bit different and things like that. There's also some changes to like the window manager and to libweston itself and things like this, to like some small pieces we're missing. But generally those are pretty small. Like the bulk of the changes is in the RDP backend.
Next question was, do we have plans to upstream some of this work? And yes, we mentioned we're planning to upstream all of this. Questions about whether or not the RDP protocol was documented. There's some links in the Q&A IRC indicating yes, the RDP protocol is extensively documented, with the exception of the veil extensions, which we are actively working on documentation for.
Well, I guess we could move to LinkMob's question. So, have you tested this setup with FreeRDP running as the client side? It sounds like I could use it for remote Linux to local Linux integration locally, smiley face.
So we have not recently did it. Like early on, we were actually using FreeRDP also like on the client until we fixed a few things in FreeRDP to actually make it work correctly with MSTSC. So since then, like we haven't run very much with FreeRDP as the client itself. But like eventually, yes, like the goal would be to be able to like this is just an RDP server, so you could connect to like any client as long as like you support like the Rail protocol and these things. But FreeRDP does.
There's one more question that we discussed earlier that I want to throw out there, which is the question of WL Subsurface. Steve, if you want to talk about that.
Yes, like for Subsurface, at least for our V1, the plan is to basically flatten them inside of libweston. So to basically make them look to the host as just a regular WL surface, don't know the difference. Eventually, we may decide to go and extend the RDP protocol to be able to just send the subsurface and their like relative positioning, etc., so that we don't actually have to essentially introduce a copy or like a flattening inside of libweston. But at least for V1, that's going to be okay. Right now, we haven't found a lot of application that actually uses subsurface because we don't actually handle them like very correctly and like almost nothing broke. But before we ship, we will have like support for them.
Very good. Just a comment from Timur, who says, "Good work, guys." Then Simon Sir is asking, how do you handle X11 creating new windows for submenus?
That's fine. Like the compositor doesn't really care like what kind of window they are. Like it's like a visual is just a visual. If you create like any type of visual top level on the X side or Wayland side, those get basically remoted over and they get put into the exact same location. So that's why in the presentation I was talking about like the way that Rail works. The very first thing that we do is we mirror the desktop, right? So your X11 desktop looks exactly the same as your Windows desktop. The same number of monitors, same orientation, same position. If anything changes, we reflect it immediately, so they're always in sync. So application knows where they are, and if they create like a menu at a specific location, well, on the Windows side, when we proxy that visual, it's going to be at exactly that location as well. So things translate.
Okay, and the reason why Simon was asking this is because some X11 apps do not set the parent-child relationship correctly. But apparently it's not impacting you in any way.
Yeah, yeah, like we'll see. Like there's still some issues right now where we're trying to track down, but in general, it shouldn't matter whether there's a parent-child relationship. If you're like independent window and you kind of position yourself at a specific location on the desktop, you'll be on that specific location on the desktop on Windows as well.
Very good. Then Micro Hobby is asking, will Microsoft work on the Weston style decorator?
What do you mean by Western style decorator?
Now comes the problem with the asking through IRC. I guess what he meant was the server-side decorations.
You mean like, for example, like the window looking a little bit different?
So
Because like for X, like the window manager inside Weston goes and render like the non-client area of like the windows. We're not looking at like changing it and trying to make it look more like Windows. Like we're kind of happy using it. Like your window will look a little bit different, but there's a lot of window anyway that basically just go and render their own non-client area. So things already look a little bit different. If you look at the Notepad versus Teams, for example, they already kind of look different.
Okay, well, yeah, but I guess that was the question, and apparently he's not been doubting that I was wrong. Oh no, he said yes, so I guess that was the question. Okay, did you have to modify also the compositor of Windows to fit this these changes?
The compositor of Windows, no. Like, so we're using basically like MSTSC, like on the host. It's the same as MSTSC that we've been using for forever, that you used to just TS onto a machine. We did some changes to MSTSC, but they're very minimal. They're things like, so for example, when you launch WSL, we automatically go and launch the system distro, launch the compositor, and connect over RDP so that you don't see anything and everything gets like set up. So by the time you launch the first app, it just immediately pops up. Like there was not a way, for example, to establish a connection with RDP without them popping up a menu to basically go and say, hey, we're establishing a connection, wait a little bit. It's like, well, we didn't want that, right? So we added, for example, a silent mode to it. So various kind of little things like this to kind of polish the experience and kind of make it better, but nothing kind of really big and functional because RDP already supported like concept of like remoting app and Rail versus Veil.
Okay, well, it seems like it was the last question. So, well, we are 3 minutes and 30 seconds early. So, if someone really...
I was going to say, if we do have time, there was an earlier discussion around DRM Buff and zero copy and MPO planes that Steve might want to talk about a little bit.
Yes, so to get to zero copy, with VGPU, we intend to get to a true zero copy, so we can share the buffer all the way from, say, and share the buffer like with the host, and then those buffer are directly consumed by our compositor. So and our compositor basically has kind of like two mode of operation. Oh, sorry, my video just froze.
It's okay, at least your sound is still there.
Our compositor has kind of like two mode of operation. So if the buffers like align and everything like this, we have this concept of like a hardware display plane. So we can have the display controller like go and directly fetch pixels from those buffer. Or depending on like what's currently on the desktop, we may decide to just recompose the desktop because maybe we gave the plane to another. Maybe you're multi-mon and you're playing a video, and the video has a higher priority to get like the plane, for example, than your Linux app. So maybe the video will get like the display plane, and then the other app like will get like compose, depending on how many display plane you have on your hardware and things like that.
And did you want to talk about DRM Buff versus not for sharing resources?
Yeah, for DRM Buff, like, so we've been chatting with folks about like whether we should try to go and implement like DRM Buff or not. The main reason, so what we're trying to do is we're trying really hard to not to look just like a regular Linux. We don't want to go and do anything proprietary that basically like all of a sudden all software breaks and doesn't work correctly. So we want to try to get all the interface between application and the system, but just be standard. And only in framework and things like this, we need to go do things that kind of adapt because WSL is a little bit different, like because we're running inside a virtual machine, etc. We've looked at DMA Buff in terms of like, hey, should we use DMA Buff, for example, to share buffer between, say, Mesa and the Wayland compositor? The problem right now is the DMA buff is not completely standalone. So there's still, although you pass the DMA buff, both sides kind of know that these buffer were allocated with DRI, and basically you need to go and use DRI to figure out like what's actually those buffer, etc. So because our driver is not DRI based, those protocol already don't work out of the box. So because of that, we're looking at possibly just adding another protocol between, say, Mesa and the Wayland compositor to be able to pass buffer that are DevDXG friendly. And hopefully that should not impact application themselves. That should only be hidden like in frameworks like inside of Mesa and not leak outside. And for application themselves, it just look the same and hopefully work. But that's not the part we've implemented yet. Like right now, we kind of brought things up like on software rendering. And that's kind of what we're going to introduce first in our insider pool so that people can start using it soon. And then as people play with this and Jesse and team finish like the work on the layers, then we're going to work on merging all of this together so that basically we can have like GPU acceleration in with like the GUI app and zero copy and all that cool stuff.
Yeah, it sounds like the discussion, or not the discussion, the talk from James Jones later on, the buffer allocation talk and workshop should be of interest to you. Yep. On this topic. Very, very good. Well, that was it. So thanks a lot for this talk, and see you in 9 minutes.
Thank you.
Thank you.